All right, so a lot of times we learn a topic and then we talk about how that can apply to business, and generally there's a lot of topics that have application in economics. That's why we tend to talk about that more than other fields of business, but there are definitely applications other than economic ones, but those are the easiest to talk about. So in Business Math 1, you should have talked about finance questions. So this is going to be a little different from that, though. This is more from the perspective of the business owner. So we're going to talk about something called total future value of an income stream. This is how businesses try to figure out kind of what they're worth if they're trying to sell to someone. Because, you know, the business is not only worth money because of what it has done in the past and what it's doing now, but also by its ability to generate income in the future. So it's basically the future value of a business when you know what money will be generated each year and you know the interest. So sometimes with a formula like this, a business owner would have to kind of take a guess, but it can at least get them kind of close. Okay, and what I mean by take a guess is they would have to take a guess on how much money they think would be generated each year, okay, or go by past events. So don't get too intimidated by the way this looks. I promise this is going to be an integral that we can figure out. So it's going to be e to the r times capital T power, and then it's going to be the integral from 0 to t of some revenue function, and then e to the negative r to the little t power. Okay, we're going to take this a step at a time. So I promise it won't be as bad as you might think. So A is the accumulated amount, just like it was in Business Math 1, by the way. R of T is the yearly revenue that you're expecting. For our purposes, that's almost always just going to be a dollar figure. Okay. T is going to be a specific, capital T is a specific time period. So in other words, like you might say, I want this calculated for the next 5 years, and T would be 5, capital T. Or I want this calculated for the next 10 years, and that would be 10. But little t is just time in general, not to be confusing, but it's the variable time. In other words, instead of x in this problem, we're using the variable t. And then R, no shocker since we're talking about interest, is a rate, but just make sure you know that that is as a decimal. So like if it's 5%, it would be 0.05. So if you can get past the way that these problems look in the beginning and the numbers that we happen to have, I think you can do this. It's just that, you know, real life numbers are usually not pleasant. So let's say a business is expected to generate $40,000 per year in revenue. T years from now. In other words, little t is our variable, like I mentioned before, for the next 5 years. Let's say that income is reinvested at 12% per year. That's just where the interest comes in. And I want you to find the future value of the business after 5 years. So in other words, we have this income being generated, but then also the business owner is earning interest on the money he has earned each year, and he's kind of investing it back in his business. So find the future value of this business after 5 years. Okay, so the first thing is you just have to know how to set this up. So let's use the formula from above. So A is going to be e to the rate, which is 12, right, 0.12, times time period, which is a 5-year window. 5 is what we have here. And then it's the integral from 0 to the same time period for the top limit. Okay, so we're right here. Now we're going to plug in the investment. Notice it's 40 grand a year, so 40 grand goes here. and then e to the negative 0.12 t power dt. Okay, so all I did was plug in the numbers that I was given for that problem. Okay. All right, so before I start, I'm going to move everything that's a constant to the front. So I'm going to move this 40,000, and then this will be e to the 0.6. In other words, I'm going to multiply those out. So I haven't really done anything other than I just wanted to isolate what I had here. Okay, so I really just moved that out to the front and kind of simplified that exponent. Now notice, I don't have e to the t power or e to the x power. I have e to some weird power. So this is a candidate for substitution. So I'm going to let u be the power. So the derivative of that u would be this. Okay, remember notation here. So let's talk about what I have. Okay, I have here e to the u. But notice I don't exactly have du here, right? So let's talk about what I want. I actually just want it to be 1. Because notice there's no number at all there. So I actually want it to be 1 dt. So how can I make an adjustment and get rid of that? You always just do 1 over a number when you want to get rid of it. So I can multiply by 1 over that, okay? And then it would be du. So all this is the adjustment. This is the adjustment that must be made so that I get something that works, that gives me the 1 dt that I want. But I still need to change my upper and my lower limits. Okay, so my upper limit is t equals 5. Lower limit is t equals 0. But I want to change them to be in terms of u. So u is negative 0.12 times 5. So this is going to be a decimal, but that's okay. We can handle that. And then here, if I plug in t equals 0, I'm going to get negative 0.112 times 0, or 0. So, most important part, can you rewrite it? That's the question. So first we have that constant that got moved to the front. But now we have a new integral from 0 to negative 0.6. And then we have 1 over negative 0.12 e to the u du. Notice here I'm just rewriting what I wrote here. Alright, so this is just a constant as well, so I'm going to pull that out to the front too. So I still have 40,000 e to the 0.6. I could enter this in on the calculator. It is important to note that I don't want to be rounding at multiple points in the problem, so I just pulled that out to the front. And now what is the antiderivative of e? It is itself, and then I still need to evaluate it from my new limits. So as ugly as this is, your calculator knows how to handle it just fine. So I've got this weird ugly constant, and now I'm going to plug in negative 0.6 and 0 into my e to the u power function. So let's just use the calculator for what it's for, right? It's for ugly stuff like this. So 40,000 times e to the 0.6 power, and then divided by negative 0.12, and then times parentheses e to the negative 0.6 minus e to the 0. By the way, e to the 0 is 1, but I'm just going to go ahead and put it in just like this. Okay, and notice we get a dollar amount of $274,039.60. We're going to round that to the nearest penny because it's money. Okay, so the future value of this business, given a $40,000 a year income that gets reinvested, is $274,039.60. Now, by the way, if you did 40,000 times 5 and you just didn't reinvest it, it would only be 200,000, right? So they got a bump of $74,039.60 because they reinvested their money, right? They earned interest and they made that work for them. All right, so that's future value of an income stream. Okay, so now let's talk about present value of an income stream. So just like it sounds, future value is what we anticipate the business would be worth in the future. And present value is what we anticipate the business is worth right now. Okay, so this will be the present value of a business. Again, when you know the money that will be generated each year, and you know the interest rate. By the way, I'm not going to ask you to memorize any of these economics formulas. So we've done problems like this in the past this semester, and I haven't made you memorize any of those. I don't plan on you having to memorize these, but you do need to learn kind of that A is accumulated amount, that R is rate, and so on and so forth. So you do need to know like what the letters stand for, but just definitely plan on getting that given to you. So this is going to be the integral from 0 to t, t being the time period, of the revenue, and then e to the negative RT dt power. If you compare that with the one above for future value, it's very close, right? It's just missing something here, okay? They're actually very similar formulas. It's just we don't have the constant in front. So in a lot of ways, this is actually easier because we don't have that extra e thing to worry about. All right, so let's practice this formula. All right, so an owner has two options for renovating his business. Okay, so here are his two options. Option A is he puts up $250,000 in cash to pay for the renovations, and if he does that, he or his team of people expects an annual revenue of $630,000. So that's his first option. Option B is maybe he doesn't want to put up as much cash, so he's not going to invest quite as much in renovations, so he puts up $180,000 in cash. And let's say if he does that, he doesn't expect quite the revenue bump from that, so he will expect an annual revenue of $580,000. By the way, the only reason you would do a renovation is if you expected to get paid for that, right? If you expected to financially benefit from that if you were the business owner. All right, so for both options, so both of these options are for the next 3 years. And interest is 10%. I want you to tell me which one has the highest present value. In other words, if he's looking at this objectively, which one should he do? Should he put up more money in hopes that he has a higher revenue source, or should he save a little bit of money and choose option B? Okay, so notice I asked you to find present value. So let's go through these. So the formula for present value, remember, is the integral from 0 to the time period in question, which this is only 3 years long. And then the revenue for part A was $630,000. And then it's e to the negative rate times t power. Okay, so that's what I have. But then also we need to think about this. You also are going to have to subtract off $250,000 when you're done. In other words, he had to put out the money, right? So we're going to have to kind of not consider that much money, right? Whenever we figure out how much it's worth, it's going to be minus $250,000 because that's what he had to put out to make that happen. So in the end, just make sure you subtract that answer in the end. So let's move the 6,300,000 to the front. And then don't forget the 250,000. If you think it's too ugly, just subtract the 250,000 at the end, okay? Because it's not really going to come into play for our integral at all. So we're going to let u be negative 0.1t, okay? We're going to let that happen so that I can write this as e to the u, which is much nicer to deal with. The derivative of that would be negative 0.1 dt, okay? This is just notation. Okay, this is a subtraction. This does not come into play here at all. So if I want to have what I really need, right, I need to make an adjustment. I need to get rid of that. So I need to multiply by 1 over negative 0.1, and then I'll have du like I want. So let's talk about the upper and the lower limits. The current upper limit is 3. So if you plug that in, you get negative 0.3. The current lower limit is 0. So if you plug that in, you get negative 0.1 times 0 or 0. So really important, here we go. This is what we end up with, 630,000 times the integral from 0 to negative 0.3. And then I had 1 over negative 0.1 e to the u du. So I'm going to move that fraction out. It's a pain, I get it, but really we're just having these weird constants kind of at play here, that's all. So now let's take the antiderivative. The constant stays, 630,000 over negative 0.1. But the derivative of e is just itself. Antiderivative, I mean. Okay. Derivative also. And then I need to say, hey, I still need to plug this in. So the reason I keep leaving these ugly constants is, again, we do not want to round in the middle of a problem. We want to round one time. So it's going to be e to the top power minus e to the bottom power. And then don't forget your minus 250,000. Technically speaking, I guess I should have written it all the way along. But this is why I say, hey, maybe you just want to subtract it at the end. Just don't forget. Okay, so if you subtract it, you'll get a present value of $1,382,845.21. Okay, so we're going to circle that. Okay, so option A gives us a present value of a little bit over 1.3 million. Okay, so let's compare that to option B. Okay, now I'm going to use a shortcut on option B because I already did this problem, right? It's just the numbers are going to be a little different, right? Instead of 630,000 for the revenue, it's going to be 580,000. But the interest rate's still the same. But then my original investment I have to subtract off is a little different. So if you don't like this, you need to just do the whole thing separate. But I'm just going to use the u from above. In other words, can't you see it's going to be the same? Like, isn't the power of e the same as what we had up there? In other words, I'm just going to skip to this part and kind of replace it with the numbers that I have. So if you want to fill all that in, you can. But this is just going to be 580,000. So I'm just copying this line right here, okay, over negative 0.1. And then e to the negative 0.3 minus e to the 0. Okay, so everything's the same, and then don't forget we're subtracting off 180,000. So when I say use the U from above, you could repeat all the same steps and you would still come down to this right here. So in the end, it's 1,323,254.32. So if you compare those dollar figures, notice option A gives us this much in present value and option B this much, right? So you should choose option A. Okay, because it's going to give you a little bit higher present value. In other words, it's worth you spending the extra money. That's what it's trying to say. Okay, it's worth you spending the extra money to do the renovations. All right, so for the last kind of pair of economic application here, or economics applications, we're going to look at something called consumer surplus and producer's surplus. So consumer surplus is, as a whole, the difference between what consumers are willing to pay before they just stop buying the item altogether. Because one of the principles of economics is, for the most part, if you increase the price enough, people will stop buying it. So, how much, the difference between what they were willing to pay for a product before they said, hey, I'm not paying that, okay, and between what they actually pay. In other words, like how much wiggle room is there, okay? And the formula for that, we'll call it CS for consumer surplus. It's going to be the integral from 0 to something we'll call x bar. I'm going to tell you what x bar is in a minute. And it will be capital D of x, and then this is just notation. Okay, right? So don't let that confuse you. It's just the antiderivative of d of x, okay? And then minus this quantity. Okay, so let's define what these variables are. D of x is the demand function, right? Because consumers control demand. X bar is the number of units sold. And P bar is the price per unit. Okay. And if you want the consumer surplus, you do this calculation. So we'll practice one of those in a minute, but before we do, I want to talk about producer surplus because it's pretty similar. But it comes from the side of the producer, in other words, the business owner. So it's the difference between, now notice they don't control demand, right? They control supply. So it's the difference between what price suppliers receive for an item or a product and the lowest amount they would be willing to take. In other words, they want to sell it for the maximum amount, right? But there's probably some low ball number that they're willing to accept. And the producer's surplus is the overall difference between what they actually get and the lowest amount they would be willing to get. So the producer's surplus is P times X minus the integral from 0 to X of capital S of X. Notice the differences here is instead of subtracting this amount, it goes to the front. And instead of talking about a demand equation, we talk about a supply equation. Think of it this way. Producers don't control demand, right? They control supply. Consumers control demand, producers control supply. All right, so again, you're not going to need to memorize these equations, just how to use them. All right, so let's find the consumer's surplus at a price level of $8 for the demand function P equals 20 minus 0.05x. Okay, so notice that we are given that the price is 0. Sorry, not 0. Price is 8. Price can't be 0, right? We're not going to get to buy something for $0. Okay, so notice we know the P, but we also need to know what the X is. Okay, so let's solve for X. In other words, let's plug 8 in. So 8 equals 20 minus 0.05x. So if you subtract 20 and you divide by negative 0.05, you're going to get that X equals 240. So we have two quantities. We know that the price is 8. We know that the quantity is 240. Okay, you need both of these quantities to be able to figure out either consumer or producer surplus. So here we go. Consumer surplus is the first one I gave you. So it's the integral from 0 to 240, because 240 was the X I just found. Okay, and then of the demand equation, which was 20 minus 0.05 x dx. And then you're going to subtract whatever the price times the quantity was. Okay, so this is just a constant, kind of like the one in the last where we were just going to do the derivative and subtract it at the end. That's really all we're going to do with that. So by the way, you do not need U substitution for this. Okay, there's no need for it. We can actually do the antiderivative without any trouble. So the antiderivative of 20 would be 20x. We would pull down the constant, right? And then we would bump the power up by 1, multiply by x to the new power. But then we would need to plug in 0 and 240. And then don't forget, we still need to subtract off of this once we're finished. And that, if you check that on a calculator, comes out to be 1920. Okay, so this is what we have. We're going to have something minus something else, and then minus the 1920 at the end. So all I need to do is plug in 240. So this is going to be 20 times 240 minus 0.05 times a half times 240 squared. When we plug in 0, you're going to find this for these problems. Notice that if you plug in 0, it's a little bit unnecessary, right? It's just a big fat 0. So if you'll work this out ahead of time, you're going to get 3360 minus 1920. So I already pre-figured these out, so I want you to make sure you punch this in the calculator and you actually get 1,440. Okay, so that is the difference between what the consumers paid and what they would have been willing to pay before they said, nope, I'm done, I'm not paying any more than that. Okay, and remember, this is consumers, sorry, as a whole. It doesn't mean each consumer, you know, left $1,440 on the table. That's not what it means. All right, so find the producer surplus at a price level of $5 for the supply function P equals 0.01 x squared plus 0.1 x plus 3, where x is units of 1,000. Okay, so this is going to require that you pull out your algebra skills. Okay, I think the algebra can be the most difficult part of this. But notice, you were given that the price is $5. Okay, P with a bar over it just means the price right now. It means the price could change. So now we need to find X. Okay, so we have an equation that's equal to P. So we're going to say 5 equals 0.01x squared plus 0.1x plus 3. So bear with me here. We have a squared equation. We need to find out what x is, so we're going to set it equal to 0. Okay, so there's a couple of things. You can either factor this. That's what you do with squared equations, or you can use quadratic formula, whichever one you are most comfortable with. Okay, factoring looks like a challenge here, but it's actually not if you just get rid of the decimal point. In other words, what could I multiply by that would get rid of the decimal for me? I could multiply by 100, and then let's talk about what happens. I'm still going to get 0 over here, right? And I'm going to get 1x squared plus 10x plus 300. Oh, sorry, I forgot to subtract my 5, right? So that should have been a minus 2. So this is going to be minus 200. Like I forgot to do 3 minus 5, right? But notice I should know how to factor this, right? So this is going to be x. What factors of negative 200 add up to 10? X plus 20, x minus 10. So it looks like I get 2 answers for x, but one of them doesn't make any sense since we're talking about quantity. So notice the negative one has to be ignored. So the only one we need to worry about is x. So x bar is 10. So make sure you're using the right equation, right? So we want producer's surplus, right? So producer's surplus would be price times quantity minus the integral from 0 to 10 of this function. Okay, so 5 times 10 is 50. That 50 is just going to stay. We're just going to subtract off the answer once we're finished. So let's go ahead and do the antiderivative. Okay, so I'm going to use parentheses here. So if we bring down the constant and we multiply by 1 more in the exponent. Okay, so instead of saying 0.01 times 1/3, I'm just saying 0.01 over 3. Here I'm going to bring down this, and then I'm going to bump the power up by 1 there too. And then here I'm going to bump the power up by 1, and then plug in 10 and 0. So here I end up just getting, I'm just going to plug in 10, and then kind of like the last one, you can plug in 0 if you want, but you're just going to get a big fat 0. So let's plug in 10. So 0.01 over 3 times 10 cubed plus 0.1 over 2 times 10 squared plus 3 times 10, okay, minus 0. Just remember that the answer you get, again, I want you to practice this on your calculator, is going to be 11.6 with a bar over it, like it repeats the 6, but this is in thousands. Okay, so the answer is actually in thousands. It's actually $11,666.67. So if it's in thousands, you've got to move the decimal place 3 times. Okay, if it happened to have been in hundreds, you would move the decimal place twice. So I think it's the factoring and the algebra that's really going to kind of test you on this. All right, so last thing. In economics, we are striving for a concept called equilibrium. Equilibrium is where perfectly supply equals demand. So equilibrium price is the price where supply equals demand. In other words, it's the perfect price where every item in the warehouse gets sold and all the customers are happy and the producer's happy because he sold all his items. Okay, it's kind of like a unicorn. It's difficult to achieve in real life, but that's what we're striving for. Okay, so equilibrium quantity is the quantity where supply equals demand. In other words, it's that perfect quantity where no customers are left wanting your item and you don't have extras and Everybody's happy? Okay, so you may have some problems on the homework where you have to actually find P and X if we're in equilibrium. So we're not going to do this problem all the way through for time reasons. But past the point where we find P and X, this is a problem that we've already done before. So let's say that you're given both of these equations. And I want you to tell me what the price and the quantity needs to be set at if the market is in equilibrium. Okay, so that's the key to this problem. We want the market to be in equilibrium. In other words, we want supply and demand to be equivalent. So we're going to set these equal to each other, and then we're going to try to solve, and we're going to try to make this as easy as we can. Okay, so I am going to move these terms to the right, because to be honest, I like dealing with positive numbers when I can, especially on the first x squared term. So I end up getting 0 equals 0.3x squared plus x minus 40. Now, here, just like the last one, I could either factor or I could use quadratic formula. Okay, my preference is always factoring when I can, but occasionally you might have to use quadratic formula. But I certainly can't factor this the way it is, so I want to get rid of one decimal place, so I'm allowed to multiply by anything that I want as long as I do it to every single term. So this would be 0 equals 3x squared plus 10x minus 400. Okay, or just use quadratic formula if you're uncomfortable with what I'm doing here. But here is where you would want to incorporate AC method. Okay, if you don't know how to factor this, you would need to do AC method. I'm not showing you the steps for that, but if you factor this out, you're going to get 3x plus 40 if you use AC method, and then x minus 10. So we get x equals negative 40 over 3, and x equals 10, but only one of those is valid, right? This is no good. So we have that the quantity is 10. And now that we know the quantity, now we can find price. Okay. Notice I have two equations up here that talk about price, so I don't care which one you pick, but I always pick the nicer one. So I'm going to pick the first one. It's got less terms. So I'm going to find the price if I plug in 10 for x. So if you work this out, you're going to get 60. So the price is 60, the quantity is 10, okay? And notice we're not going to do it because we already practiced one of these each, but now you could find, now that you know x and p, you could find both consumer surplus and producer surplus, okay? Just remember that when doing consumer surplus, you'll use the demand equation. When doing producer surplus, you'll use the supply equation. Okay, so there might be a problem on the homework where you have to do this all the way out, but from here on out, you can do it just like examples 3 and 4 in this lesson.